Here at the University of Arizona, we make the largest mirrors in the world. So astronomy is limited by light gathering power. When you want to look far in the universe or look for faint stars or exoplanets, you have to gather as much light as possible. So the push is on to build bigger and bigger telescopes, and we're building the mirrors for those big telescopes right here. So the mirror behind me is one of what will be 7 mirrors, all of this size, that will go together like flower petals with a central piece to make the biggest telescope in the world, basically a 24-meter optical telescope called the Giant Magellan Telescope that's destined for Chile. And we, University of Arizona and Stewart Observatory, we're 10% partners. This is a $1 billion project. This is big science in every sense of the word. My name is Chris Impey. I'm a University Distinguished Professor of Astronomy at the University of Arizona. And I've been here for almost 30 years doing research on supermassive black holes and distant galaxies and teaching astronomy. Panspermia, sort of, microbes and comets. This online course, Astronomy, Exploring Space and Time, is the culmination for me of teaching to a very wide audience to try and convey the excitement of astronomy and especially the research that's going on right now, which is all around us at Stewart Observatory. So this course is an overview of astronomy. Nothing is left out. We're talking about everything from comets to cosmology, and we're talking about how we know what we know. That's important. How can we prove or understand the universe 13.7 billion years ago in the Big Bang? How do we know what it's like inside a star? How do we know there are planets that might have water on them light years away? So the method of science, shows us that we can use evidence, remote information, remote sensing, light, and other electromagnetic radiation to learn these things. And then we talk about the tools, and these are the amazing new tools of astronomy, these huge telescopes and also huge detectors. And so the progress of the class goes inside out, starts from our neighborhood and works out through the solar system to twins of our solar system and perhaps Earth clones that we might be finding, into the architecture of the Milky Way and all the exotic end states of stars, which are interesting to a lot of people, black holes and neutron stars, places where relativity is dominant and where space and time are warped and distorted, and then out into the universe of galaxies. And then talk about the whole thing, cosmology, the study of the universe as a single entity. These tools are very sophisticated and very expensive. This Giant Magellan Telescope will, in the end, cost about $1 billion, so this is big science. But astronomy really starts with curiosity. It starts with something that costs nothing. It's built into every human brain, the curiosity of where we come from, what is our position in the universe, and what's the nature of the universe. So I hope everyone enjoys this class and interacts with me and the material and gets a flavor of modern astronomy.
I'm going to teach this class with the title, From the Big Bang to Dark Energy. What this class is really about is these questions, where we came from and where we are going. You have probably heard of the fact that the universe started with the Big Bang. The universe was incredibly tiny, actually much smaller than the size of an atom. Then it started to expand tremendously, and it has become as big as what we see today. Then, how did the galaxies form? How were the stars born? Where the atoms come from? These things are all related to the question how the universe began. So we would like to understand the connection between the universe we see today and how it began. At the same time, where we're going depends on some mysterious force called dark energy of the universe that is speeding up the expansion of the universe. Depending on the nature of dark energy, which we don't know yet, the universe might end up with a big rip, or it may go on forever, heading to a big freeze. We don't know which is the right fate of the universe yet. So I'd like to introduce you to these subjects by using really basic calculus and high school physics level knowledge, and that would cover this material starting from the very beginning of the universe and hopefully some possibilities on how the universe might end.
Oh my God, it's full of stars. Hello, my name is George Jargovsky, and I'm a professor of astronomy at Caltech. I will be teaching a class, Astronomy 1, The Evolving Universe. This class is offered to the first-year students at Caltech. It requires a solid understanding of freshman physics, but it will not be very technical. What we will be learning about are the contents of the universe, starting from planets and stars all the way to galaxies and the universe as a whole, how they form, how they evolve, how do they work. But more importantly, how do we know all that? How do we measure things? And how do we interpret that? How do we use physics that we know on planet Earth to understand the universe at scales that we cannot possibly touch? We'll be talking about our own solar system and other solar systems, about stars and how they work, about our own galaxy and other galaxies, and even larger structures in the universe. We will end with some of the outstanding questions of cosmology, because astronomy is very much an evolving field in itself. So I hope that you will enjoy the class and learn some interesting things about the universe, as well as about astronomy as a science and how it works.